Okay, so in the previous tutorial, I think we have covered all of the jump related features, and now let's look at much more advanced concepts, right? So the first thing I want to touch is distance matching, because you see now our locomotion system is pretty much accurate, but still, let's say if I move to a forward direction, you can see at the starting we have sort of a foot sliding, right? Oh, it's not a specifically foot sliding, but let's say the pawn's velocity is not properly matched with the animation's frame, right? Which means, like, let's say at the initial stage we shouldn't have sort of a quick animations that is being played, otherwise it seems like our foot placement and the pawn's velocity drive is in different states. It's very noticeable at the pivotal change. You can see, like, when I'm moving a pivot direction like this, you can see there is a foot sliding, right? So in this pivot, actually the character should stop, right, instead of moving, right? But instead he is sliding through the ground. Okay, so this issue actually can be fixed using distance matching. So let's see how we can do that. So in order to use distance matching, first you should enable a plugin called animation locomotion library, right? So let's quickly enable this plugin, right? So you may have to restart the engine. Okay, it will take some time, right? So once it's restarted, I'll open up the previously opened tabs, right? So once that plugin is enabled, you can use those distance matching based nodes in your anim instance, right? So yeah, can we start this distance matching? Right. So let's start from the start state onwards. Then progressively we can apply those distance matchings for the cycle, pivot, and stop, and even some of the state in the jump state transitions. Okay. Right. So let's go to the start. And here we have this update start anim layer function, right? So currently what we are doing is we are simply advancing the time for each frame evaluation, so it simply plays the animation, right? But instead of that, now what we need is drive our animations speed based on the pawn's velocity, right? Okay. Yeah, can we start? Yeah, we have this stride warping alpha. Actually, stride warping is trying to achieve somewhat similar thing, but it actually changed the foot placement, or like the distance between foot based on the velocity, right? So for example, let's say if we have a slower movement, then the foot placement will be much closer, and if we have a speed movement, then we have sort of a distant foot placement, right? So this stride warping will be used to achieve that foot bone manipulations. But distance matching is actually syncing the animation frames with that exact specific velocity change, right? So it would be much more convenient for the player, and it would be much more realistic movement. right? Okay. Mm, so I'll simply remove this pin and connect it to here, and instead let's use advanced time by distance matching. Okay, so you can see this advanced time pin comes with the sequence evaluator library, which is a default animation library provided by Unreal Engine. But this distance matching comes with animation distance matching library, which is a plugin that we just enable. Okay, so let's use that on here. And for the context, I can use the existing context. And for the sequence evaluator, I think I can use this pin, convert to sequence evaluator return value. Right. Okay. And then for the distance traveled, I think we need a new variable called distance since last update. Do we have that variable? Distance? No, we don't have it. So I think we have to create it. So let's go to the functions and blueprint thread save functions. And there we have update location data. Oh yeah, we have this variable displacement since last update. Yeah, we can reuse this variable here. So I'll simply attach it to here. Displacement since last update. And we need a new distance curve, right? So if you look at the animations, like for example, forward start cardinal, here we have this distance curve, right? So based on the value provided by this distance curve, we can apply those distance matching capabilities at the enemy instance level. So the curve name should be actually distance, right? And as usual, what I did for the other curves, like here, let's promote this to a variable. I'll call it as curve locomotion distance curve, right? And add it to here. Okay. Now we have the curve, we have the displacement since last update, and now we need to assign the play rate clamp, right? So do we have the play rate clamps for the variables? No. Right. So let's add those play rate clamps variable for our data table. Right, so in our data table we have this config, so we can add one more config for these play rate clamps, right, which will be used for the distance matching. Right. So maybe I will go to the let's go to the data structs locomotion moment. Yeah, this is the configuration we want. I think I'll add a new data structure and I'll call it as sanim config underscore distance matching, right? And inside this data struct, let's define set of fields, right? The first field we need is play rate clamp starts, which is the type of vector 2D. Similarly, we need play rate clamp for what? For cycle, and maybe play rate clamp for stop, and finally play rate clamp for pivot. Okay, right. And as the default values for the play rate clamp start, I will provide it as 0.6 to 5, and I'll copy the same thing and paste it for other stuffs. And for the pivot, also the same thing. And maybe for the cycle, instead of having this value, I can have like a larger value like 0.8, and for the maximum, let's have 1.2. Okay, now this should be goes under SNM config. So I'll add a new variable called distance matching, and let's apply that structure to here. SNM config distance matching. Save, and let's go to the SNM moment. Yeah, the things have been broken. Right, so let's reassign everything. You're good to go. Yeah, maybe I'll pause the video and do the reassignments, and I'll show you the final result. Right, so I did all the reassignments. Now you can see our final SNM set data structure is good to go. But as usual, if you go to the data table level, now we have lost all the previous data. So let's re-import it again, and it gives this distance matching related fields are not found at our JSON entries or JSON output. But that would be fine because these are the new fields that we have just right now. Okay, so make sure to take a JSON backup for your data table before doing any sort of data structural changes, right? Because such inconsistencies can be happen at runtime. Not at the runtime, actually, development time, right? Okay, now rest of the stuffs are there. All you need to check is our distance matching field. Yeah, so I will use this pre-configured value for now, and later on, if required, we can make some adjustments. Okay, let's simply try the commotion as well. Yeah, everything works as usual, I believe. Yep. Okay, now let's go to the ABP locomotion, and as usual, let's go to the set animation data, and here we have config, and now we have this distance matching. So let's break it out, get it here, and what to do. Yeah, so let's promote everything for variable play rate clamp starts, play rate, clamp, cycle, play rate, clamp stop, and play rate, clamp pivot. Okay, and I'll assign these to a category called maybe distance matching. Compile and save. Okay, now let's go back to our function where we left off, which is update start anim layer. Now we can use those play rate clamps to resolve these values. Okay, so first I will get the play rate clamp start, right? And break the vector, and let's get the stride warping blend in duration scaled. And I think these are the settings that I added previously at the stride warping section. So in case if you missed that section, please go through it. There actually I have added these variables, right? So these are pre-configured values actually. These are not taken from the data table instance. Data table instead it's simply configured values at the anim instance level. Let's slurp it with the output of x, and for the alpha I can use the stride warping alpha, stride warping start alpha, right? And let's make vector 2D, and for the x I will use this one, for y I'll use this one. Okay, plus I think we can add one more play rate clamp for sprints, right? Because if you are sprinting we may need to have a different level of play rate clamp. But yeah, for now let's keep it like this, right? So maybe I'll add a to do called consider sprints, right? So in case if you missed to add that feature, maybe later on we can address it out. But I think even within this play rate clamp it would be pretty much fine, right? Okay, now we have the distance matching for our start any layer. So let's play test it. Okay, great. Now you can see actually at the starting also we don't have a foot sliding, right? Great. Okay, now maybe I'll stop here because otherwise it will be too long to cover the entire thing at one episode, right? So let's say within this part 1 what we have been covered, we simply add the distance matching for start animes, right? So maybe at the part 2 maybe I'll add the distance matching related features for the rest of the states. Okay, so I'll see you there. Thank you.